So what I'd like to do is go over some of the things I talked about yesterday, elaborate on them, and also I'd like to open up the molds and the parts that I made yesterday. So there's a lot going on with composites where a lot of attention to detail. Now normally when you built a model airplane, the only thing you had to worry about is the grain direction, plywood or balsa wood. With composites, it's almost infinitely variable. So you got carbon fiber, Kevlar, fiberglass, all these different weaves, 1K, 3K. It gets sort of confusing. And me personally, I'm a modeler. I'm not an engineer. I'm not a chemist for chemicals. So basically it's a lot of tinkering and experimenting. And for me to find out what works, I almost have to get samples and mess with it. Going forward on some of this composite stuff, I'd like to narrow it down to where it takes some of the guesswork out of it. I can't cover everything, but I can cover specific topics as I go along that might help. So even though you don't build an airplane out of composites completely, which some people have, you still will find a use for composite carbon glass within the model, whether it be to beef up a bulkhead or carbon spar or whatever. So you can insert composites into a wooden airframe with really good success. So I'm going to go over a couple things. These molds here were in the oven yesterday, and I'm going to bring the camera around here and I'm going to show you what these things are. And it's an attempt to reinvent the wheel. So there's never been a better case of reinventing the wheel than this little thing here. So the idea is to make a wheel for control line stunners that's durable, that doesn't wear out. So that tells me you almost have to get away from the foam rubber to an extent. Now there's all different diameters of that. Now this here, this was a little experiment. This is an O-ring. And you can get these things in all different diameters, material, you know, it's just a hardware store. The trouble with this O-ring type material is, talking to John and a few other people, you're getting into this no cushion. There's a lot of noise, it rattles, you know, so when you land you got a noisy wheel where the rubber transfers, at least at this level, you know, the lightweight stuff transfers a lot of vibration in the airframe. The foam rubber, the softer stuff, it's softer, it's quieter, but it wears. So what I need to do eventually is find the ideal tire, and that's the tricky part. So what was in the oven yesterday are these little parts. So these are redesigned. This was used to make this wheel. As you can see, there's there's not enough room here in the center of the hub for, you know, washers or wheel collars or whatever you'd use. So I beefed this up. So in order to make this larger, I ran a 1/2-inch drill bit and sort of made a countersink. Now all this is variable, you know, you can change this, you can make it square or whatever, but composites like nice soft angles. So the idea is to take your carbon fiber, lay it on this mold, Of course, you'll have this pin here to center your axle. To compress your carbon fiber onto this mold, there's another mold that was cast, and this casting actually comes over the top of your carbon fiberglass or whatever, and then it sandwiches the material, and then you clamp it, and then you post cure it in an oven or a room temp or whatever your resin might require. So it's just a two-part mold, and to come up with the wheel, which would be the carbon fiber or glass. So to make these, I chucked them on a lathe, and of course the tool bit comes in, and you just peel away a little material right here until you get the depth you need. Now of course this is doubled, so I just calculated half of the O-ring, and that's how I came up with the depth of this flange. Now if you're using thicker tires, what you're going to have to do, or what I'll have to do, is come in here and make another cut to make this deeper. And the idea is maybe eventually, instead of actually sliding the tire on, maybe it's actually putting the tire on the wheel, and then of course these two halves are glued together, so you're basically encapsulating the tire in between these, wheel halves. So that's what I did yesterday. That's just aluminum bar stock on a lathe, and I polished it, and then I made these castings. Now these were post cured in the oven all the way up to 300 degrees, so I figured I'd be casting or making parts up to 250. So I cured these to 300. So I started out at 150 for a couple hours, made sure it was good and soaked. 200, 250, and 300 for an hour each time. This is 302X Resin Services Surface Coat, and I've used it on many molds. I backed it up with a 560 casting epoxy from Resin Services. Now, a roundabout way to get the mold made, what I did is, it just so happens, of course this is a 2-inch wheel. If you go by 2-inch PVC, the ID is 2 and roughly 3/8. I don't know, it's over 2 inches. I put this on the lathe and I countersunk a ring around it. So this is what forms the casting, the PVC. And that just fits on there like that. And I don't even seal that up. So the 302X surface coat, once you get this on there and set it on there, the surface coat won't seep under that. If it does, it's very minimal. This cut here was made intentionally because I knew that once this casting was made, the only way to get this off easy was to actually peel it. So what I do is put a screwdriver in there and torque it, or it allows you to get something in there to twist it to pop it loose, and once you get it to break loose, you can sort of peel it off your casting, and these are reusable. So that's where I'm at right now with these. I think it's pretty close to being operational. I think I've got this where I need it to be. These are O-ring tires. It's for an RC plane. But eventually I'll make more discs. I've got blanks here. I went to metal supermarkets. These are a little bit bigger. But I'll machine these down, and then probably for a deeper wheel. Now one of the things I'll probably do, and it'll be in a video later, is instead of cutting tires like RC cars out of foam, like with a hole saw, the donuts, I'll probably come up with a method to mold the tires. and that way I can alter the durometers, and they've got a urethane rubber or some kind of rubber that expands, and it expands in the mold. Depending on how tight the mold is how much back pressure you get. It determines how much density is in the rubber. And the other beauty of it, it's like the Dubo tires, it's self-skinning, so as this expands in the mold, it forms a smooth surface on the outside. So that's a whole nother process, but once I figure out this, and I'll figure out the optimum width of the tire, which would probably be around 3/8, and then I'll start machining more molds, and we'll experiment with the actual tire material. So these little discs, these were pre-preg, and it's just a matter of putting your layers in there, closing it, and then cooking it. This could be wet layup also. The advantages of pre-preg is obvious, and the disadvantages are many also. But you're allowed to lay the fiber in the mold exactly where you want it. So here's a little scrap piece I made up. I don't know if you can see it or not, but I was able to get these pieces positioned side by side to where it's basically, there's, other than the visual pattern, it's almost like one. Now obviously if you run carbon here and there's a seam, you've got to back it up with something on this side. Otherwise, you know, it's going to break on that seam. There's no continuity in the fibers on that. So you can do a lot of things with wheels. The other thing I've got is some carbon fiber Kevlar mix. They have it colored to where it's red or blue or different things. So that was an experiment, but in order to use like a pre-preg, you've got to be able to control the molding of it. And it's not like hand lay, it's not as forgiving. It's easier in some ways and harder in others. So that's it in a nutshell with these molds. Another thing I'm going to talk about is these landing gear. I molded up 3 of them yesterday, 1 of them on camera. And one of the gears I made was one like this. Now this landing gear, it's a little bit more narrow. This was the first one I made. And this gear, I guess I call it a defect, because when I made it, it had like little voids, like right up in here. It had just little pinholes, sort of like that a little bit. And this was made without a gel coat. It was just laid in the mold right on the PVA release. So all these little things show up. Now what I'm going to do with this gear, I'm going to actually sand it and probably paint it. But it's got the properties I want. So a gear, an older gear, I've got some molds that are good for maybe a heavier airplane, or let's see if I can find them, such as this. So this is an older profile here. This is the master part. So what I've done is I tried to shrink it down, and I think it's about the same thickness, and it came out lighter. Not a whole lot lighter, but it did come out lighter. So anyway, we're going to open the mold from yesterday and take a look at what I've got. And then here's another one I fixed up. This was the first one I laid up also of, well, the second one. So I had like little pinholes here, little gaps. Nothing to really affect it structurally, but anyway, I went through there and fixed it up so it's still usable. Yeah, Steve, good morning. It's an oddball time to be doing this, but I thought, you know, I've got probably an hour to waste out here, so I'm going to come on here for a little bit, show you what I did yesterday or the results of it, which will be new to you and me also. Now, yesterday, if you watch this live stream, I get to about an hour and 6 minutes, and the thing ends. It just shuts off, so there's something either within my internet connection or my cell phone or whatever, it times out. And that's something to be figured out later, I guess. So, I'm not going to go an hour, but I'll go half hour, 45 minutes here today. And then we'll cut it off. Another thing, sort of rambling on here. This part here, it's sort of like the old bell cranks I made, but it's got a forked end on it. So Bob Hunt was talking probably the way to improve it the most, but it complicates things as far as making it. And I'm trying to simplify it, and I want to make it like I did the old bell cranks, the carbon. What he was talking about, the old way is take the lead outs and run them through like this. So then your lead outs are pivoting, you know, like that, through a tube. You take an anneal brass tube, you run it through another tube, and then it pivots. Well, the danger or the problem can arise to where on a heavy pull test or a line jerk, that could tighten up, and what would happen then, if the crimp tightened up on the brass tube, it would restrict your bell crank movement. So what he proposed, and a lot of people have been doing, they drop a steel pin, maybe music wire, down through this fork. What goes over that steel pin is a brass button or some kind of I don't know, something brass or something to be good wear resistance. So around that button there would be a groove, and your lead outs would go around that groove. Now the trick is not to actually make the bell crank and sandwich two pieces and then come up with a forked bell crank that way. I wanted a super light bell crank that was carbon that incorporated this fork. So what you're looking at is a phenolic mock-up. I've got the draft angle in here, and I might have to tweak this a little bit. And the idea on this is when you make this bell crank, it's going to be made similar to the other ones. So here's an old mold from what the bell crank mold would look like. So what would happen is you'd have this bell crank, you'd have a void in the mold just like this. Okay, this area where the fork goes, there's going to be a metal plate, aluminum or plastic or something, that's going to run this way. So you're going to lay up this carbon fiber just like you're laying up a normal bell crank around the pins, and then when you get half of this fork filled right here, you're going to screw down a plate. Okay, the plate is going to come down and compress the first part of this fork, and then you're going to continue on with more laps around the top of the pin, and then you're going to close the mold. So you're going to mold the bottom and the top all at the same time Once it's cured, you'll pull the pins out, these pins here, which will be drill rod. You'll pop the top of the mold off, and then you're going to unscrew this plate, which will release the bell crank. And then you'll probably come in from the side with a bigger piece of rod. You tap it, and then this plate here on the end, along with the bell crank, will come out of the mold. Once it comes out of the mold, then you'll release these plates, and there's your groove. And then insert the pins. It'll probably be like C-clips with hardened pins, or we'll figure that out after the fact. But anyway, that will give you a nice pivot with a button for your lead outs, and it'll all be one piece of carbon. So the carbon bell cranks that I was making out of these molds, they were coming out around 7 to 8 grams, and that's just the bell crank without all the music wire. So in effect, there's a lot of trouble going into making this, but once you make the mold, making these with the fork won't be any harder than making these. It'll just be a matter of screwing the plates to form the fork halfway through the molding process. So that's where I'm at on that. So this has got to be fine-tuned. You know, I'm going to put some fillet material in here and make this as perfect as I can and get it where I want it. Another thing I wanted to talk about briefly on these landing gear. They're airfoiled, and they're also, they've got a slight bow to them. It's not exaggerated. Now this RC Funfly gear, obviously, you know, that's just a, you know, it is what it is. It's made like that on purpose. But by taking the carbon fiber and putting an arch in it, you increase the rigidity of it. And if you notice on a leaf spring underneath your suspension on a trailer or whatever, your leaf springs aren't flat. Now they might be flat once they're loaded, but the leaf springs are always curved. And what that does, it sort of preloads it, and then you get more rigidity for less carbon. So this little arch here is important. And on the hangouts, it was Charles Hangout, Dennis at Emission, and Tryan. They were talking about composites, and they brought up some really good points. Tryan, he's talking about fiber orientation, how you run the fiber, how it affects the rigidity and the structure of the part. And it's all true. He brought up some good points. And then Dennis at Emission also said to get rid of an oil can effect, you form curves. So by curving and having no flat spots, basically you're making it more rigid, just like this gear. So this little RC pod, I don't know if you can tell, but there are no flat spots. I curved it here and I curved it here. So this has all got to be sanded. It's pretty gnarly right now. I put a second coat of cloth on it. So I think a lot of people miss the advantages of composites when they don't design certain aspects into the part, such as like a 55-gallon drum has got rings around it. Those rings are to provide rigidity. So remember that when you're trying to make a carbon part or anything out of composite. Don't feel like it has to be flat, because 9 times out of 10 it's probably better off curved. Steve had a question that said, how much would a set of those wheels run? Well, I'm not really sure at this point. I know the price point for a wheel. You know, a good price point for any part, and I hate to say this, but in people's mind, if they hear the magic number $20, people will spend $20 whether they think it's good or not, just to take the chance. The neat thing about this whole process is it doesn't take much material. You could take a yard of carbon and you could, make a lot of these wheels with it. So basically, the materials are minimal compared to some parts, but there's more labor in it. Now, to lay up a bell crank, there's a lot of, to lay up just one bell crank the way I was doing it was 20 minutes. I'd lay up 3 an hour. And that's just laying it up. That's not bushing it, deflashing it, sanding it, and doing all the other stuff. So the wheels are sort of like the landing gear. There's not a lot of labor hours in it. It's just a matter of taking, the mold. And obviously you have more than one mold. You might have, 20 to 30 of these molds, 50 or 100. But anyway, you just lay the carbon in there, smash it, clamp it, throw it in the oven, you're done. Now, the price, I'm thinking the happy price for a set of these wheels, if they were for stunt, where everything was perfect, let's say the weight was half of the weight of aluminum wheel, you didn't compromise anything. The tire was light, it was durable. I was shooting for like $30 a pair. That's if everything would go right. And that's what I think the market would bear. Some people pay 40 or 50 maybe, but 30. Me personally, that's, if you can go in the hobby shop and you can buy $15 set of plastic wheels that wear out, I mean, 30 would be a given for something that's very specific, maybe 40 or 50, who knows, but it'd be something in that area. But the key is to refine it, to get it exactly what you want, and then actually make a whole bunch of them to make it profitable. So I understand there's a limit to what you can get, but I try to do things that haven't been done. And I'm not saying this hasn't been done. I'm sure there's somebody out there, but there's two different things. There's doing it, and then there's doing it to where you can break even or make a little bit. So, but I'm going to experiment and I'll get there. These things here, I don't know. We'll find out. That's if I do everything right, it won't be any harder laying up the fork than it will this. It'll just be more after the fact work here. But I think people will pay a little extra to have that feature. In fact, I know they will. So anyway, that's where I'm at on the gear. Let's get one of these molds here. Crack this mold open and see what we got. Let's see. Yeah, making two thin bell cranks. Yeah, I understand what you mean. It probably would be. In other words, if you make two bell cranks with some unidirectional and stuff like this, where you'd make these wafers. And then the balsa would be the core. That's another option. I think I can make it lighter and better this way. I'm going to try this. I like a bell crank with forks with continuous toe all the way through. Now, one of the problems with carbon, people say, well, let's make a carbon bell crank and let's make it to where it's out of this, which is fine. And it's probably overkill. I'm not saying that this isn't good, but I mean, technically, if this wheel was perfect, the carbon would be running the length of the spokes, and the carbon out here would be going in a continuous circle in an optimal world. But, we're just pressing it in there, which is overkill. So, yeah, Steve, that is a viable option. Yeah, stunt hanger. He can't believe I woke up. So anyway, let's open one of these things up. See what we got. See if I got the mold filled right. Let's see here. Trying to figure out which one I'm going to do. These things are so heavy once I get these clamps on them. Now, I've done this before on videos, different gear I've made. So this isn't anything new, but out of curiosity, the people that watched yesterday maybe haven't seen it. So the first thing I do is take these plates off. They popped off. These only had wax on them, so it came off really good. Let's see, which one is this here? This is the thinner. This gear coming out now is this one here, the second generation. Now I'm not going to do this over the glass. I'll show you how I demold this thing real quick. It's convenient because I have the ears on this thing. You see right here the overhang. So what I try to do is just tap these ears. Now this gear mold was pretty tight when I made the mold. Let's see what we get here. Now what you're looking at is the PVA. Let's see if I'm in focus here. And the PVA allows pretty much a easy release. It just peels right off. Now, I've had good luck with free coat release, but the mold was post-cured, like a high temp mold. I mean like 350. Might have even had it to 400. I can't remember. I know it was up in the 300s at least. And then I used the chemical release. So you can see the PVA here. See how that, it's like a bad sunburn. So a little flash there. Now to get these things out, I've always, see if I can stay on the camera, come in here on the side. And I start it down here on the leg. That's where I start demolding it. See if I can slip this razor underneath there. Once you get it started, it comes out really easy. Supposedly. Dig it out. Maybe this one is, it's not stuck, it's just a matter of getting it started. This razor has been dull, so it's not something that's sharp. I'm seeing the edge off of it a little bit. Get under that edge. Now, a lot of times, some of these molds, I'm able to extend the carbon out. And I'm able to pull on it. This is a new mold. Once they're seasoned a little bit, I think they come out easier. Sounds like it's starting to come up. You hear it crack a little bit. Alright, let's go back to the ends here. See if I can tap it out there. Sort of hear it coming out. This one's in there pretty good. I'd have to get a bigger hammer. So it's really, the resin's not glued in there, it's just a matter of, it's almost like a suction's holding it down. Alright, so I think I got it pretty much broke loose as far as around the edges. Now, put the hammer on it here in a second. Okay. once you get half of it pop loose, the other half comes right out. Might have to do a little repair on that. It'd be nice to build in something to where you could get to it. That might be a problem. I might have to put more carbon down here, let it extend past. So anyway, what you're looking at is the PVA. Now once this PVA is cleaned off, and then you got a matte finish. So I'll show you here. I spray that in there to where it comes out like a satin finish. So a mental note is a little bit more carbon so I can get underneath it. I had this thing in there so tight, didn't have anything to push against or grab a hold of. Now normally when I clean all this PVA off, what I do is I just throw them in some warm water and it all melts away. So it's got a sort of a satiny finish. And one of the things I'm going to experiment on is a glossy finish with maybe carbon weave. And then of course a Dremel tool, or just take a sanding block, go around there and clean the flash. It goes pretty quick on these. Repair that a little bit. It takes usually about 3 or 4 of these till I get it all down. But it didn't stick. I mean, it didn't come out real easy, but it didn't tear anything up. So that's good. PVA is pretty much foolproof if you wax and then of course this down here doesn't have any PVA on it. It's just waxed. But you know, you still get a release. You can see the epoxy comes off the mold with just wax, but it comes off a little bit harder than with PVA. Alright, there's that one. Let's get that out of the way. Let's get another one up here and see if I have any better luck. I had a couple of these in the warming box, and it was these two. Now I've got a little box down here with a heat lamp in it, and this heat lamp, it usually gets the box about 100 degrees, 110, which is, if you take a room temp cure that's supposed to cure at 77 degrees and you cure at 110, it becomes very happy. Let's see if I can tap this one down gently. Well, put this on the floor too here. There we go. So this gear was the RC gear, little fun flyer. Yeah. Yeah, meat pull tabs. Got half of it. Yeah, a lot of times on the end here, I build it up with a little bit extra carbon. It gives me more to grab a hold of.